Hey everyone, we are going to complete the identity you see on your screen right now, which is sin x over cosine x, single fraction, plus cosine x over sine x. Now, if you opt to try to complete this identity by jumping into changing this, here just to point out, changing, and anyone watching without listening is going to regret this, but into tan theta plus cotan theta, I would have to say that's sort of not the best, because what your goal is whenever we complete identities, rewrite these, any of this, is really to try to bring everything together and use as few plus or minus signs as possible. We want it to be as compact into one package as we can. Now, how do we bring two terms together, especially two fractions? Well, the way we bring two fractions together with addition or subtraction is by finding a common denominator. So we're going to find a common denominator for this one. What does that mean for us right now? Well, that means we're going to take this one right over here and we're going to multiply on the top and bottom, or numerator and denominator, by sin x or sin theta, because this has a cosine on bottom, this has a sine. We're going to have one of each. They kind of have nothing in common. So it's like having x on bottom, y on bottom. Your common denominator, lowest common denominator, would be xy. If this was a 2 and a 3, your lowest common denominator is 2 times 3, also known as 6, right? So I'm going to go right over here, and this is going to be sin theta over sin theta. And again, ask yourself, why are we allowed to do this? Well, because you're multiplying by 1, and multiplying by 1 is totally allowed. It's known as the multiplicative identity, and we're always allowed to multiply by 1. Now, I just kind of got rid of that. Sorry if you don't have that same luxury. Got rid of that. So I'm going to go over here. Sorry, that's so wonky. We're going to multiply this on top and bottom by cosine theta. All right. So what does that get me next? Now, here's the deal. You have your common denominator, sin theta. This is times, not minus. Sin theta, cosine theta on bottom there. And then we have the same idea, sin theta times cosine theta on bottom there. So I could be a little bit smarter here. I could draw one big fraction bar, right? Just straight across. And I could just write sin theta, cosine theta in my denominator once. All right. Now, what do we have on top? Well, here I have sin theta times sin theta. What does that become? If you said sin squared theta, you're so smart. Plus, now I have cosine theta times cosine theta. And what do we do with that? Cosine squared theta. Beautiful. Now remember, your goal is to get this nice and compact. When these little squares start coming up, we're like, oh, how nice. Pythagorean identities can be used. So think about your Pythagorean identities. The classic original one is sin squared theta plus cosine squared theta equals what? It equals 1. So we're on our way. We're cleaning this up. And now we have 1 over sin theta cosine theta. Now, while this is looking a lot nicer, we want to do something else. We also, whenever we're simplifying, okay, a trig expression and cleaning it up and rewriting it nicer, whenever we're doing this, we want to avoid having anything in the denominator if at all possible. So right now I have a sine in the denominator. I also have a cosine in the denominator. And I can use my reciprocal identities. So one way I like to read this off, because of how you could save so much time here, is I like to say to myself, sine on bottom, in other words, sine in the denominator, is the same as cosecant on top. And when it's on top, we don't have to write over 1. It's not like this 1 is going down there. This 1, in fact, it's still up there, okay? This one is still there, and there's another one down here. There are two different ones, okay? So that 1 on top is still there, all right? And I'm going to indicate that a little bit with colors in a moment, because some people don't get this. Cosine on bottom, well, what's that the same as? That's the same as secant on top. Now, as you see in the step prior to that, there's nothing I could do with secant and cosecant to cross stuff out, all right? They're cofunctions and they're not reciprocals. There's not really anything I can do with them. So they're just sort of just staying as they are. And this is what I just wanted to point out. So this 1 in the numerator is still in the numerator. This 1 doesn't go anywhere, but the 1 in the denominator, this guy right over here, I mean, it could still be there, but we never have to write either of these ones. I point this out because when they're not a 1, when they're something like a 2 or a 3, I don't know, people think that they have to move those as well, and they're not going anywhere, okay? They don't have a negative exponent, and we're not dealing with any type of reciprocal for them. So those are done just as they are. So I would say the clean, beautiful final answer can be cosecant theta, secant theta. You can put parentheses around each of them. You could put a dot in the middle of them. It doesn't matter. I hope that this example works for you. It could have started like this, gone then to this, to here, to here, to here. We could make it more complicated. So yeah, if you have a different approach, a different idea, put it in the comment section down below. If in general you feel pretty good about all of it and you understood and at least understand your way and you're able to do this, give a thumbs up. If not, stressed and depressed, put a thumbs down. And otherwise, click through for the next example. And I hope you are feeling smarter after this one. Adios.